we've talked today about a lot of the new things that we've put into Spatial Modeler, but we want to also give you a little bit of information about what you or your customers can do to make Imagine theirs, to customize it and make it meet their needs. And we're going to start with one of the things that we've done that is really easy for a user to do, and that's to automatically add a button to run a process to My Models tab. And I'm going to demo this live. So the information is here on the slides, and you can refer back to it if you want to, when you have the slides. But I'm going to go now to actually live demo. And so let me bring up Imagine and just show you how it works. So first we're going to start with creating a spatial model. And this is going to be a very simple spatial model. This is going to be one that generates R sets. So I'm just going to create my model here real quick. Put my operator on, put a port input. Ian talked this morning about the importance in 2016 of port inputs. Well, and outputs too, but mostly for inputs. And so I'm going to double click that and give this port input a name. Spell. Okay. And so basically your model can be anything. And so this is a very simple model. You do have to have a port input because it's going to want to ask you for your input, for what file or what parameter or thing that you want to use when running this model. And it does that via the port input. And so what I have here is probably the simplest thing you can have is one port input and one operator. But it can be as complex as you need for your task. Once you have your model, then the easy thing to do is you just go to this button right here, Add to My Models, click it. It's going to ask you for a few things that it may get off of the model itself if you've set it, but if not, it will ask for them here. And so it wants a name, and I'm going to call it Generate RSets, and a category, and I'm going to call it NIDA, and I'm going to go ahead and give us an icon so that we can distinguish it from others, and I'm going to give it a description. Okay. So I set up the information, I click OK, and magically I get this tab here. When I click on it, I have a new button. And it has the name that I just gave it, Generate RSets, for the name of the button, the category I gave it for the group that the button is in, and the icon that I gave it, which was this No Pyramids icon, as the icon. So let me actually close my model here, just so that we've kind of clean. And if I click on this, I will get, I get the process list, but then I get this Generate RSets dialog. And you've seen that probably already at least once or twice today. The first thing you can do is you can view your model if you wish. You click on Edit, and it does open it in the editor, and you can change it or you can just view it. It does not get, whatever changes you make here do not get applied back to what you're going to run here, so don't be confused by that. That's just it's a copy that you're viewing or that you're editing. You, of course, can batch, and so you click on Batch, and it gives you the command line that it's going to use, and in this case you would have your raster file names that you're going to variabilize, and it's got the column where you can fill that in. And you can do all your normal batch things. So I'm not going to run it yet. Let me go back to my Models tab, and then as we've had for a while, you can customize your ribbons. You can add this button that you just created to your quick access toolbar. And so now it's up here so that it's ready for you at any time from any place in Imagine. So now I'm going to go find my image. Do I have it in the... Oh, I don't. Pardon?
You have a shortcut to training.
Yeah, well, it was on my in my recent list this morning, and then I logged in as a different user. And so anyway, so I go off and I generate my RSets. And this will take a little while, because I don't know that there's a particular need to watch this going. So while this is going, I'm going to go talk a little bit, show you a little bit about what's actually happening here when you create the Mind Models tab. In this Explorer window, I'm looking at the .imagine 1600 directory for this user, which is me. And there's now a models directory here. And if I click on that, you will see that there's a model in that directory. And that's the one that we just created. It got put there. And so when Imagine starts, it looks in this directory to see what's there. And we'll read this model and get the name and the display category that it uses for the group, et cetera, out of the model and make put that on the My Models tab. Now what I can do makes it really easy then. What's the wrong one? This one. To share my buttons with somebody else, my model buttons. So here I have a directory, a models directory, and I have a few things in it. And so I'm just going to take that and I'm going to drag it over here. And just for ease, I'm going to copy it. So now this is my Imagine 16, .imagine 16 models directory. And I have a couple of models. I also have a directory. And it contains one model. So let's come back over here and let's see if our process is completed. So now I can close this and I can close Imagine. And then when I restart Imagine, it's coming. Okay. And I go to my Models tab. Let me just kind of pull it over here next to it. You'll see that I have a colorized DEM model in a DEM tools group, and that's because in the colorized DEM model it says that the display category is DEM tools, and the generate RSets one, like I just made with the NITIF group. But then I have a photogrammetry group here, and that's because I have a photogrammetry folder. And so you can group things on your toolbar, my models toolbar, either by using the display category name in the model itself or by putting things into folders. And so you can have, I could have multiple models in photogrammetry folder. I could have multiple folders, and then they would be groups on this tab to help organize the buttons you have on the tab. Okay. As I said, this information is here on the
Can you copy just about any model into that directory?
Any model that has a input port, one or more input ports.
One or input port.
Okay.
And then, but you also you select the icon to represent that. If you just copy a model, that is not associated with the particular icon.
Well, there's always an icon. There's a default icon that we use is block.ico.
Okay.
And so you will end up with something. It's not
what you want.
distinctive. Mm-hmm. And you do need to give it you should give your model a name, and you should give it a group, category. if you don't give it a name, I think the default name is spatial model. So again, it will have something. It just will not tell you very much and not give you much information to know what it is you're going to run.
So the best thing to do is that if you have an existing model, is to load it onto the canvas, and then say, import to my model, right? And then you have the interface so that you can specify the.
Yeah, you can actually get to that in other ways.
Yeah, that interface is the same as the operator info.
Right. So if I go
this morning, that will feed that dialogue if it's present.
Yeah, and it
right.
Values.
The order in which the ports have been created, the dialogue appears in that order.
Right. So if I this operator info group here, if I bring this up and make it a little bit larger so we can actually see it.
Was there a way to change the order?
Yes, you can.
Well, and but that's for the properties. But the name and the category and the actually I guess this is the category and this is the name. I don't know why we're missing the words category and name here.
120% font.
I was going to say probably the font size. And the icon and the description, everything is in this panel that you have for every model you create. It's just that we don't enforce you to put anything specific here. But when you do publish, we ask you for that information because it's a little bit more in your face, and so it comes up into, but it will get the information from this panel. If you filled in the information here, that's what's saved in your model, and it will retrieve that and fill in this dialogue here, the add to my models dialogue. So you don't have to enter it twice. But we do stick it up in your face and just to make sure, yep, that's what I want before I add it to the tab.
But it's called operator info, not model info.
Well, it's because a model is an operator. An operator is a model.
That's true.
So.
But how to get it? Do people know that you have to select?
That's what I went through this morning, that if you want to create a reusable model, you have to do these things now. You have to put port inputs on, you've got to give those port inputs names and descriptions for their bubble health. You've got to make sure they've got the right port settings, so it props up the right button on the menu. You've got to set this operator info for the name and description of the model. If you want a reusable model, you have to do all that stuff to start with. And it shouldn't then really matter when you come to publish it to Apollo, send it to SmartMap, or put it onto my models tab. You've done all that work already.
Yes. So yes, one thing just to be clear, if you're in the editor and you have an operator selected, then what you see here in this panel, which I've shrunk down again, I can make it a little bigger just by making my window bigger. But anyway. What you have is the information for the operator you have selected. If you click on the canvas and you have no operator actually selected, then the information you're seeing is for the model.
Yeah. I knew that, but I was not figuring out for a while. Then I kind of hit up on it. Oh, that's how I get it.
But it is the same information, and we just put it in your face when you actually create when you add a model to the My Models tab. But like I said, if you've done that, and so I have a models directory in my, I don't know which one it is now. Yeah, my Imagine 16 directory, and you want my models, then I can just copy that directory over, and that information, of course, is already there.
Is it right for me to put it on any tab I need to? If I want that to be on my home tab, for that matter. Can I?
You can use the customize.
Yes, you can use.
This is a shortcut that you don't have to mess with customize ribbon. That's what was asked for. I don't want to go in and use customize ribbon. Because we've been able to add models as buttons since 2015.
No. From here, can I tell it to display on a different tab rather than my?
Not automatically. You can once it's on the tab, then you can customize.
Okay. You can still do it. Okay.
Although I don't know.
No, I think you can.
I don't think you can customize my models, but you can customize an existing tab to have the button that is your model.
So, but it's not. But when you say add to my models, that is the tab that puts it on. Is the only tab that puts it on.
And this dialog that comes up for this model, can you bring up that dialog again? No, not that one. The actual model dialog.
Oh, can I run the thing?
No. Well, yeah. So
This?
Yeah, this one seems to have like edit, preview, run, batch. If I don't want some of these things, can I control that?
No. This is an automatically generated dialog that gets, that has these pieces on it, and then it has places to input the values for whatever input ports you've got. And Ian was showing that this morning, of what, you know, when you have multiple input ports.
You as an ERDAS IMAGINE engineer can control it by building a proper dialogue for running your model, not using the auto-generated dialogue.
This is the auto-generated.
What happens then if I do preview with this?
Well, this one, it won't do anything because it doesn't have a preview operator in it. If it had a preview operator in it, it would actually try to preview.
So, I know, that's a...
So, but this one does not have a preview operator. So, all right, Kumar, enough of your questions. You can ask me questions anytime. I need to actually do
Any questions from the audience? No questions.
Okay. So again, these are what I just talked about. Continuing on with another thing you can do is you can actually use Python with Spatial Modeler, and the basic capabilities are you can either create or execute spatial models via Python, or you can embed a Python script in your spatial model. So those are the two basic capabilities. There are a number of different, pretty much anything you can do in Spatial Modeler, you can do you can create that via a Python script, and pretty much any Python script can be run from your spatial model. So you've got a lot of control there, and that can give you, if you can do Python scripting, you can actually do some of the looping that Ian talked about this morning that we don't have the ability to do right now, et cetera.
So in Python, you can just import all the operators from from Imagine, and then you can use your Python language construct, and then do your programming, essentially, do your scripting.
You can do your scripting. You can't do things like you cannot get to pixel values. So you can't access specific pixel values. You can access like members of tables, elements of tables or matrices. You can create files, read files, input, output files, that sort of thing, but you cannot get to pixel values. You cannot get to the streaming types. You cannot get to their pieces. But then even if it's not streaming, you can get to. And we've had that now since 2013. I mean, that was something that we've done in Spatial Modeler since 2013, is had Python. But changes for 2016 is we are changing the version of Python that we support. We're supporting Python 3.4.x, and we supported 2.7x previously. This is a new version. And I noted here at the bottom that there are significant differences in the Python language between 2.7x and 3.4x, or 2.7 and 3.4. And so you cannot guarantee that the Python programs that you wrote in 2.7 will work in Spatial Modeler, even if you now have 3.4, if you don't go change those models, those scripts, to work in 3.4. So it may require changes to your script if you wrote it in 2.7. And it depends on what, some of the functionality that you used in Python. A lot of it is completely compatible, but there are some changes, and you are likely to encounter some things that don't work, that you have to change. You set it up by doing configure Python from the file configuration menu. And we automatically support both 32-bit and 64-bit. So if you have, it is recommended that you install both 32 and 64-bit Python. That 32-bit is required for Spatial Model Editor. If you want to run your model in Spatial Model Editor, you must have 32-bit Python, because spatial model editor, as delivered by Imagine, is a 32-bit process. If you want to run your models that have that use Python operators, you want to run them in the background or in a batch mode, and you're running 64-bit SM process, then you need to have 64-bit Python. If you only have 32-bit, your models will not work. You have to have the version of Python that matches the version of the 32 versus 64-bit version of the executable you're actually running. But we will switch. So you configure one, and then we will switch automatically from one to the other. And if you try to import into your script an older version, then we will tell you that you do not have the right version of Python. So I think that covers the version information for Python. Some of the other things that we have done for Python for 2016, the library import is faster. It used to be a little bit clunky, and we've sped that up. We've given you the ability to create and inspect more types of data from Python. Like I said, you cannot get at pixel values, but you can get at a lot more of the data types, including dictionaries and lists. And you can create a lot more of the data types than you could previously by using the JSON representation. And you can get that sort of thing usually if you save a value on an operator in a model. It will be persisted in JSON, and you can see what that looks like in your, to then create that using Python.
Why can we not get access to the pixel value and
we just don't have we haven't come up with a good way to give these or that ability yet.
Okay.
It's, we've discussed some things, but we haven't. It's one of those things that it's just not real clear how the user would access something like that. And we haven't found out the way to make it.
Matrix.
Well, yeah. So we haven't figured out exactly what we want to do with that yet. But
what is the advantage? I'm just the devil's advocate. What is we can build a complex model using spatial model editor, but we also could build a very complex model using Python script, and by calling the spatial modeler operators. What is the these are two approaches of other than that we can get into the stream data and pixel data. What is the pro and con of each approach?
Well, I mean, I think it depends on a couple of things. It depends on, one, the type of user you are, whether you're someone who likes to do things by dragging and dropping, or you're somebody who likes to type. But the one advantage, as I mentioned, of doing something, or one thing that can be done with Python that cannot be done in Spatial Modeler itself is the looping, while loops, that sort of thing. So we can kind of do the for loops now, but we can't do the while loops. So we can do the iterator, but we don't have a while loop. And that is something that you can do in Python that you cannot do in Spatial Modeler.
You could take other technologies and use that output from this into a mix and match technology. Like you can bring MATLAB Python into this and take the output from our modeler, if we were able to give them array of pixels, manipulate using MATLAB, then feed it back in.
What about your in ArcGIS, your object?
Yeah.
That too.
So your sophisticated user could use the Python script and write a program that you mix and match imagine processes with the ESRA, your vector cleaning operations, etc. That is very much possible, right?
Yeah.
And also Python as a mature scripting language, it should have all the programming construct that would be required for any sophisticated programming. While Spatial Modeler does, we have iterator, but we don't have looping. So
So I would like to see somebody have write a Python script, write a build a Python program that use ArcGIS and Imagine, and or even maybe GeoMedia to do things. Not necessarily having to embed those them as operators. Right now we're using GeoMedia stuff by by forcing it into operator, right? Can you communicate on the Python level?
I don't think GeoMedia in itself advertises to be able to talk to Python, but we have reverse engineered QC, which is COM, using COM libraries of Python to actually make COM calls through Python. So if you could do that, you could probably use any COM library, import it into Python through the COM importer, and then use that to do any operation. One of the things would be is to do the kind of operation that Frank was asking about, doing some kind of repetitive batch processing. And you can make very complex logic, put into your Python, run it on a batch process. It's far more easier to run a batch process of Python than to take an exe and run it.
Yeah, so this would be something that we should I don't know, we should explore this and show to our customers that they can mix and match technologies and making and create a very complex and powerful solutions. Okay. Any question from the audience?
At the end of the
okay. So Frank says awesome. Thank you, Frank. So continue.
Okay. Well, one last thing here is that another thing that you can do now in 2016 via Python that you could not do previously is control the raster processing. As Ian said, we got rid of the processing properties and we introduced the defined processing area operator. So in 2015, you could not get to the information that was then only in the processing properties. And so you could not set your window or your coordinate reference system or anything like that from Python. And you can actually do that now because we have an operator, and you can create and set the ports on that operator to do that. So it gives you a little bit more control. Moving on. Frank had a request for having a way to automate a process by watching a folder for data. And so he worked with our QA team, the Firehawks, and they created a Python tool they're calling the Watch Bucket that allows you to run any ERDAS IMAGINE batch command, including Spatial Modeler, by watching a folder when some data appears in that folder, then automatically processing it. This particular tool requires Python 3.4, 32 or 64-bit, but it does have the restriction. This is simply a prototype. This is not a product. But so it has the restriction of it's looking for Python to be installed in a particular location. It's looking for it installed in Python C:/Python 3.4. This is included. There's a zip file with this that was included in what was sent to you guys. But we also will soon be available on the Hexagon Geospatial community as an example of something that users can do. You would take that zip file that you've got and you unzip it. It doesn't matter where you unzip it to, as long as you have access to it. And then you have to install this watchdog module into Python, and the direct information is there about how to do that. And what you do then is, in what you unzip, there's a program called watchbucket.exe, and you double-click on that and start it, and it brings up a dialog where you set up a few things. You have to set up, where is your Imagine home? What folder do you want to watch? What do you want the output folder to be? So when data is generated, what folder do you want the output to be put into? What's the extension of the files you're looking for? And what would you want for the extension of the files that are output? And then you have the command that you want to actually use. And all this information gets saved into an INI file. So you specify here on this dialog what INI file it is, or where you want to save that INI file. You create the INI file, and then you can run it. And then there's a log file that gets created, and you can just monitor the log and monitor your input and output directories. So, Frank, do you have any comments? I'm going to run the little script or the little movie rather, that Firehawk sent. Do you have anything you want to say while I'm getting that going?
I was just going to say that I think, thanks for doing this. I've showed it to a few other AEs, and everybody thinks it's really good functionality. I'm not sure which example you want to show here, but I've run this on NDVI as a kind of a test. I've done the a Dodge Plus spatial model, and it's as simple as, maybe you're going to show that, but drag and drop it into the watch folder, and it automatically processes. And then it gives I think there's a reporting mechanism as well. But yeah, I'll just let you go ahead and, but that's all I had to add.
Okay. So anyway, you've got this is actually the demo that Firehawk's put together on how to do this. And they're showing here in the upper left, the directory where they unzip their quote installer into, and then to the right of that, the upper right, is kind of their directories where they've got some of their input and output going to go, and they're going to have I guess the input there. The lower left is going to be the output for one process, and then they're just going to actually chain two processes together, and so then the output of that process will go into a watch for a new process, which then the output of that will go into the folder on the lower right. And so let me go ahead and continue their movie here. And so they're starting the watch bucket program, and they're going to set up the Imagine Home directory, and then specify the watch folder. And so it's going to be their input folder here. And the output folder for this one is going to be the one folder here that's on the left. And they're inputting last files. What they're going to do, actually, let me pause this a second and explain, is they're going to convert the last files, the point cloud files, to raster, and then from that create a DEM. And so the first piece is creating the raster, and the second piece is creating the DEM. So this is the first one. So we're taking the LAS files, going to output IMG files. And so if you stop here real quickly on the command, you can see that they're running a point cloud to raster model, and they've got the parameters for the input name and the output name. And then they're going to save this INI file. Okay, save it. Okay, now it's real tricky. They're going to go back, leave the dialog open, but go change the directories now. So now the output file becomes the input directory, or I'm sorry, the output directory becomes the input directory, and a new output directory. And so now they're looking for IMG files is input, and IMG files is output. And then there's, let me pause it, whoops, not quite quick enough. There we go. This particular process is a model called Relief, and again, it has an input DEM, so an IMG file coming in and output raster going out. So they're now going to save that INI file. So they've got two different processes they want to run. They're going to go to the Run tab, select the first one, open it, and run it. And so it's going to create a command window for that, and then select the second one and run it, and it creates a second command window. And so now these are the commands that are watching these two folders. And so if we go over, they're going over to this folder on the upper left and taking a couple of LAS files and dumping them into the input directory. And now we'll watch the, starts up the Spatial Modeler and processes the files, one file, and then another. And now you'll see things are showing up in the lower right window as well, because as things got dumped into the file, the folder on the lower left, then they got picked up by the next watch bucket process, and they're being processed now. The rasters are being converted to DEMS. So, any questions on that? So, as I said, this is kind of a prototype, a demo of things that could be done. There are obviously things that could be made a little bit cleaner and a little bit simpler, but it certainly is an example of a way to automate a user's process using tools that, for the most part, we already have.
Mm-hmm.
Okay, so if you want to get a little bit more advanced in your customization, you can actually use the Spatial Modeler SDK. Again, we've had this since, well, I guess formalized for a couple of versions now. Really didn't have it formalized until 2014, I guess. Really more 2015, and now even more so in 2016. It's a C++ toolkit. Lets you build and modify and run workflows. We have an entire Spatial Modeler, as I'm sure you've heard already, is done with an extensible plugin mechanism. And so, if you have the SMSDK, you can add new operators, new data types, new data conversions. You can add dialogues, the configuration dialogues when you double-click on an operator or a port or something like that. You can add those via the SMSDK. And now these tools that you add, these new operators or data types, et cetera, that you add, can go into multiple Hexagon geospatial products. So it's not just Imagine. It's GeoMedia, Apollo, Smart Maps, et cetera. Caveat with Smart Maps and Apollo is you have to get it installed on your server, which may not be entirely straightforward. You'd have to work with your server administrators, but certainly on your desktop, it can work in multiple products. And these are just a few examples of some things that we've done at various times that have been done strictly using the SMSDK. It's also available through the Hexagon Geospatial community. So if you go to you bring up the community and you click on the developer network link near the top of your screen, then that will take it pops down and you have a Spatial Modeler SDK option from there, and that takes you to this page. And on this page, you can get to the knowledge base, shared samples. So we've got some examples of SMSDK usage that are out there, as well as things like list of conventions that we use in our development that are not requirements, but are certainly things that we recommend. There's also a link to actually download the SMSDK. And you get to that via the View All button under SDK/API. And it's not entirely clear, that's why I'm telling you now that here, because it's not entirely obvious where you find that. There is different levels of access. Everybody has access to the knowledge base, articles and API documentation, and the shared samples. The API documentation is the documentation for the SMSDK itself, and that is available to everybody. If you are a Hexagon HGDN member, you also have access to the knowledge base articles. And if you actually want to download the SMSDK, it requires additional credentials, and you can get those credentials, the user can get those credentials by emailing smsdkadmin@hexagongeospatial.com. And basically, there's some additional legal work that we need to make sure that you know what it is you're allowed to do and not allowed to do with the SMSDK. And once that is, we're confident of that, then we will give a user the ability to download the SMSDK. Any questions about the SMSDK itself? I know that this is, I don't want to go into this actual programming part of it. We do have given trainings, can give trainings if people need information about actually how to do the programming. This is a little bit more high-level information that you can give to your customers about what's available to them, what they can, could do themselves. Or, of course, if anybody is so inclined, you could do it as well. New for 2016 SMSDK is the ability to work with feature operators and point cloud operators. So now all of the data types that we, the primary data types that we have in the SMSDK, the rasters, features, point clouds, etc., you can create models and create new operators that use these data types. The few other little things that I want to highlight here, that because of the way that online help is built into Imagine, it is not easy for a user to insert their online help into ours, but we did give, in 2016, the ability for a developer to display whatever they would like to have for help for their operator, so that they can, a user could have help for a custom operator. As well as we now have bubble help that you get when you just kind of hover over something. And another thing that we've done is allowed keywords as well as the categories for sorting and finding operators. And so that's another highlight of the actual SMSDK capabilities in 2016. Any questions on the SMSDK?
No.
Okay. So real quickly, I want to just highlight a little bit of what some third parties have done with the SMSDK. The first one is Geosystems, and they have done this UAV workflow, and they have a layout, a custom layout, a custom tab, which of course is not Spatial Modeler, but then all of the things behind the scenes are operators that they have created. And so they've, they did this probably developed in 2014 and available in 2015. So this has been going on for a little while. They're working on 2016 as well. And so they've done some extensive customization for their particular tool that is available. If you have customers who need that capability, you can contact Geosystems. The tool is available from them. Zayang mentioned several of these this morning briefly as well. The FuseGo model from Scene Sharp is a pan sharpening tool that they have written an operator that you can get from them that does this particular algorithm, produces a very nice pan sharpened image. Recently, Digital Technology Services Limited has developed a PDF 3D, and it is also an operator that does something, I guess, beyond geospatial PDF. We now have 3D PDF.
Well, people have 3D PDF.
Well,
okay. You can
create 3D the PDF. World has 3D PDF.
That's the beauty of extensibility.
So, yes. So they are making a 3D PDF, and they're have an operator to do that. Rapid Lasso developed the last tools a couple of versions ago, I guess. They have a lot of LiDAR tools that they have put operators around so that you can use them in Spatial Modeler and use them as part of your workflow.